Hey guys, welcome back to the channel. Today we are going to solve web challenges from WolvCTF. So the first challenge for the category is Bean Cave. Let's take a look at it. On opening the website, we can see that the website checks if the pictures we upload are the same or not. As you can see here, we are given two file input fields. Upon looking at the HTML code, we can see that there is a comment saying update outdated MD5 scan system. From this we can understand that the files are checked if they are same or not using the MD5 signatures of the files. So now let's try to upload same image in the two fields and see what will happen. As you can see here, it is showing the same image key as true. But apart from that, there is nothing interesting. So now let's try to upload two different images and see what will be the output. As you can see, there is nothing interesting here also, but the same image parameter is set to false. Upon looking at the web page properly, we can see that they are requesting for two different images, one for bean leaf and one for rust spots. So from this we can understand that we should have two different looking images but with same MD5 signatures. Upon googling for such images, we can see a Reddit thread that has a link to a Google Drive which has such images. Now let's try to download the two images and try to upload them to the website. As you can see here, we are successfully able to get the flag. Now let's get into the second challenge of the CTF, that is upload fun. On opening the website, we can see a PHP code. On looking at the PHP code, we can see that it accepts two different types of requests. One is post and one is get. We can see that the post method is for uploading the file and has conditions like limitation of file size, blocking illegal file names that can lead to LFI and empty file limitations. We can also see that the server is using client IP and the flag to create a SHA hash that is used to store the file that is uploaded to the server, making it hard to access the uploaded file. The get method is used to access the file that is uploaded to the server, and that too if we know the file name. And if we do, we can send the file name with a get parameter named f. Now that we know how the website works, let's open it up in WRITEUP and see what we can do. First of all, let's upload a file using the post method. As you can see here, I already have a template for post request for file upload. Let's change all the required parameters to our current settings in this post request. We can see upload success text in the response. This means that we have successfully put the file into the server. Now to access this file which we have uploaded, we have to send a get request with a parameter f looking like this. But there is a problem. It is that we don't know the complete file name as we don't know the hash. This is because the final name of the file in the server, as I mentioned earlier, is a concatenation of a hash that is unknown with a file name which we provide. But there is a workaround to get the hash. We can create a warning by sending the file name larger than what can be used. So on googling upon the maximum file name length, we get the answer as 255 characters. Now let's craft a file name which is 300 in length. If we send the request with this as the file name, we'll get a warning as you can see here. And in the warning, there is the hash that has been leaked, and now we can access the files that we uploaded to the server. So now let's upload a proper PHP code and see if we can execute it in the server. Now when we try to access the a.php which we have uploaded, we can see the word hello, which means that PHP has successfully executed. Now we can create a proper PHP file which can execute the commands which are sent using the get parameter. Now that we have successfully uploaded the file, let's send the command ls and see what will happen. As you can see here, it has listed all the files in the present directory, but there is no flag.txt. So let's try to cat the flag if it is present in the root directory. As you can see here, we are successfully able to get the flag. Now let's look at the third challenge of the CTF username. For this challenge, they have provided us a hint. It reads, the JWT is meant to be cracked, but the secret is not in our list. From this, we can understand that this challenge is most probably a JWT tampering challenge. On opening the website, we are given an input field in which we can enter the username. And when we submit a username, it will redirect us to a welcome page and says welcome followed by a username which we provided. On looking for the cookies, we can see that there is a cookie named appdata and it is set to a JWT. To understand this JWT, let's open it up in jwt.io. As you can see here, the username is stored in an XML format. So, in order to perform any injection attack, we can change this data to whatever value we want. So, in place of changing the data in JWT, I thought of directly sending the injection payload in the post data. So, I opened up Bubsuit and intercepted the request that is being sent to the server. Then I changed the value of the username to a simple SSTI payload. But on sending this request, I got an error saying that the username must be only lowercase letters. So we don't have much of an option other than to tamper with the JWT. So I registered myself as admin again and got redirected to welcome page. Once I sent a request with the cookie I got to know that there's a file named app.py. So for the initial step, I tried to change the data without changing the signature in the JWT. But as you can see here, we got an error saying that it is unable to decode the JWT. Now we don't have any other option other than to brute force the JWT secret, starting from 1-digit characters to 2-digit characters and so on. For this purpose, I found an awesome repo in GitHub named JWT Cracker. So I cloned the repo and started to brute force the secret. As you can see here, I was able to find the secret, and it is this 5-character gibberish word. Now that we know the secret for the JWT, we can tamper with it at will. So I went to the payload all the things repo and started searching for the XXC injection attacks. As we know that there is a file named app.py, I thought of reading the contents from it, so I took this particular payload. So, on changing the data and signing it with the secret we found, I got this particular token. I changed the cookie to this particular token and sent the request. As you can see here, I got an error saying that the references are not allowed. So I found another payload which was not using any references. And then I did the same process, changed the data and sent it with the secret we found. Using the new token that I sent a new request and I got the response back with the whole app.py as a response. Upon looking at the code, I found some interesting information like the flag is an environment variable and a new endpoint named secret welcome is present in the server. And looking upon that endpoint, I found that we'll be able to get the flag if we are successful in logging in. And in the comments, we can see that the username is flag user and the password is same as that of the Linux password. And we know that the Linux passwords are stored in etc password or etc shadow. So I did the same process to get these two files as I did for the app.py. On looking at the etc password file, I got to know that there is a user named flag user, but the password is in the shadow file. As you can see here, we are able to get the MD5 crypt hash for the user, flag user. So I loaded this hash into a file named john.txt and tried to crack it with hashcat. As you can see here, we are successful in cracking the hash and the original word is QQZ3. So let's go to the 10-point secret welcome and try to log in as flag user. As you can see here, we are successful in getting the flag.